Imagine our planet has a thick blanket of gases wrapped around it. This blanket, our atmosphere, is essential for life. Factories, cars, power plants releasing a specific gas called carbon dioxide, or CO2, in enormous quantities. This has made the blanket much thicker, trapping too much heat and causing our climate to change in dangerous ways. Carbon capture technology acts like a giant industrial-strength sponge. Its primary purpose is to soak up this excess CO2 right at the source. It is a direct intervention, a way to intercept pollution before it becomes a global problem. The process itself can be understood through a simple analogy. Think of a soda-making machine. It injects CO2 into water to make it fizzy. Carbon capture works in reverse. Special chemical solvents or filters are used to separate the CO2 from other gases that are emitted when we burn fuels. Coal, natural gas. Once the CO2 is captured, it is isolated and compressed into a liquid-like state. This captured carbon cannot be allowed to just float away. It needs a permanent home. The idea is to stop the cycle of pollution at its most concentrated point, offering a technical fix to a chemical problem. After being captured and compressed, the CO2 needs to be stored somewhere safe and secure, forever. Scientists have identified deep underground geological formations as ideal storage sites, often located thousands of feet below the Earth's surface. Porous rock layers, depleted oil and gas reservoirs, saline aquifers. Southeast Asia is a region of incredible dynamism and rapid economic growth. This progress, however, has come at a significant environmental cost. As nations like Indonesia, Vietnam, Malaysia have industrialized, their reliance on fossil fuels has skyrocketed. The region's energy demand is among the fastest growing in the world, and a large portion of this demand is still met by burning coal oil gas. This has turned Southeast Asia into a major global hotspot for carbon emissions. The air in many of its sprawling megacities is thick with pollutants, a visible testament to an economic model dependent on carbon-intensive energy. The numbers paint a stark picture. The region is one of the largest emitters of CO2 globally, and emissions are projected to grow without serious action. According to the IEA, energy-related CO2 emissions in Southeast Asia have surged by over 80% since 2000. Much of this comes from coal-fired power plants, the backbone of many national grids. Indonesia is a major coal consumer and one of the world's largest coal exporters. This economic reliance on fossil fuels makes transition politically and economically complex. The consequences are felt across the region. Southeast Asia is exceptionally vulnerable to climate impacts. Rising sea levels threaten coastal cities like Jakarta and Bangkok. More intense typhoons, prolonged droughts, and unpredictable monsoon seasons jeopardize agriculture, food security, human lives. Prosperity built on fossil fuels is now at risk from climate instability. The problem is a clear and present danger to hundreds of millions. This creates a pressing dilemma: how to grow and lift people out of poverty without fueling a global climate crisis. Stopping growth isn't the answer. Nations must find a way to decouple economic progress from carbon emissions. Carbon capture technology enters the conversation, not a replacement for renewables, but a pragmatic, necessary tool. It can manage emissions from hard-to-decarbonize industries, providing a critical bridge to a cleaner energy future for all. In response to this urgent need, a wave of carbon capture projects is beginning to take shape across Southeast Asia. Governments are no longer just talking about the technology. Major energy companies are actively investing in its deployment. Indonesia is emerging as a frontrunner. It has a vast industrial base and unique geology ideal for CO2 storage. Depleted oil and gas fields have been identified as storage sites. State-owned Pertamina is working with international partners to build large-scale CCS hubs. Those hubs aim to store emissions from Indonesia and neighboring countries. One major project is the Kasuri gas field. Kasuri's gas has a very high concentration of CO2. The plan: capture CO2 on-site and inject it into a nearby underground reservoir. Kasuri could store millions of tons of CO2 each year. This is industrial-scale decarbonization, not an experiment. Malaysia is also moving fast. Petronas launched the Kasawari CCS project off Sarawak. Kasawari will capture CO2 from a gas field and inject it into a depleted offshore reservoir. It's expected to be operational in the next few years and is one of the largest offshore CCS projects. Indonesia and Malaysia are creating a regional blueprint. Thailand is studying these models. Vietnam is studying these models. These projects mark a fundamental shift in thinking about energy and carbon. For Southeast Asia, managing carbon is as important as producing energy. CCS hubs are creating a new decarbonization industry. That means new infrastructure, pipelines to transport CO2, and new technical expertise to monitor stored carbon safely. It's the start of a supply chain for pollution control and a sustainable industrial future for the region. The push for carbon capture in Southeast Asia is critically important for the well-being of its people. The region is home to over 680 million individuals, many of whom live in low-lying coastal areas that are extremely vulnerable to climate change. By significantly reducing carbon emissions from power plants and heavy industries, CCS projects can help mitigate the most severe impacts of a warming planet. This means helping to protect communities from rising sea levels, reducing the frequency of extreme weather events, safeguarding the agricultural lands that feed millions. It is a direct investment in the safety and security of future generations who will inhabit these lands. From an environmental perspective, the stakes could not be higher. Southeast Asia boasts some of the world's most vital ecosystems, including vast rainforests and incredibly diverse coral reefs. These natural treasures are under immense threat from climate change. Ocean acidification, caused by the absorption of excess CO2, is bleaching coral reefs, while changing weather patterns threaten terrestrial biodiversity. By capturing carbon before it enters the atmosphere, CCS helps to slow these destructive processes. It is a tool that can give these fragile ecosystems a fighting chance to adapt and survive in a rapidly changing world, preserving the planet's natural heritage for everyone. Beyond environmental protection, these projects are also a powerful engine for economic progress and energy security. The development of a regional CCS industry will create thousands of high-skilled jobs in fields like geology, engineering, data science. It also allows countries to continue utilizing their existing energy infrastructure and domestic resources more responsibly while they gradually transition to renewables. This provides a stable and pragmatic pathway to decarbonization that does not require shutting down essential industries overnight. It fosters a new form of green growth, where economic development and environmental stewardship can finally go hand in hand. Furthermore, by positioning itself as a leader in carbon storage, Southeast Asia can attract significant international investment and strengthen its geopolitical standing. Countries with ample and secure storage capacity, like Indonesia, Malaysia, could offer carbon storage services to nations with limited geological options, such as Singapore, Japan. This would create a new, valuable export market built on environmental services. It transforms a pollution problem into an economic opportunity, demonstrating to the world that climate action can be a catalyst for innovation, collaboration, and shared prosperity in the 21st century. Experts looking toward the end of this decade are cautiously optimistic. Southeast Asia could become a global hub for carbon capture vision for 2030. Multiple large-scale CCS projects fully operational, collectively capturing tens of millions of tons of CO2 each year. The journey is challenging. The destination, a stable climate and a prosperous, sustainable future, is worth striving for.